Well, greetings to all you Amphaholics out there in YouTube land. In today's mercifully short video, Rusty and I are going to share with you an experience that we had while working on the second Davis Model 106 PA amp. Not only is the problem extremely rare, it's the first time I've ever had it happen, but I think you'll find the solution to the problem to be equally intriguing. That sounds interesting. Grab a beer, pull up your easy chair, and prepare to be thrilled and amazed. You plugged it into the current limiter, hooked up a speaker, turned on the power, and this is the sound that greeted you. Doesn't respond to the controls. And if it sounds like a really slow idling motorboat, that's why they call it motorboating. It's most often seen in radios and is rather rare in guitar amps, but let's analyze why it's happening and fix it. Now, conventional wisdom generally dictates that the filter capacitors can cause this problem. So let's see what their ESR values are. Remember, we've got 240s and a 30. Got a 0.63, 0.92, and a 1.3. None of these are particularly disturbing values. They all seem very normal. So it would not appear that the filter capacitors are bad. Also, the motorboating is not accompanied by a 120 cycle hum, which we would expect if any of the filter caps were really leaky or dysfunctional. Now we're going to monitor the B+ that's coming out of the 6CA4 rectifier cathode right here, and we've hooked it into a Simpson 260 analog meter. Digital meters are great for making static measurements, in other words, measurements that don't change, but for any sort of dynamic measurement, such as a pot being swept through its full range of travel, you really need to use an analog meter. Okay, now let's turn on the amp and see if the motorboating is accompanied by a disturbance in the B+. Notice that the needle movement corresponds exactly to the motorboating. So this will imply then that wherever the source is, it's in the high voltage B+ output from the rectifier. Okay, here's the first 6BQ5. Here's the second. Let's monitor the plate voltage on the second BQ5. Okay, here we see it rises up to around 320 or 30 volts. And it oscillates in rhythm with the motorboating. Now let's monitor the plate voltage on the first 6BQ5. And here's a rather strange finding. There is no plate voltage on the first 6BQ5. It oscillates, but it's essentially at 0 volts. Now, to determine if the absence of B+ is the fault of some sort of short in the 6BQ5 or a defect in an output transformer winding, I pull the tube out of the socket. So let's see what sort of voltage we receive at the pin of the 6BQ5. And the grim revelation is that there is no high voltage being delivered to the plate of the first 6BQ5. This would indicate an open primary winding in the output transformer. So let's start checking resistances of our two primary windings. Okay, first let's measure the resistance of the primary winding between the plate of the second BQ5 and the center tap. And that resistance is over here, right, I'm going to say 180 or 190 ohms. Now let's measure the primary winding resistance between the plate of the first 6BQ5 and the center tap. And very sadly we see there's infinite resistance, which means that that primary winding is open. And sure enough, when we look at the primary side of the output transformer, we see that it's a bit chewed up. I don't know if a rodent got in here, maybe one from that Jackson Golden amp. And you notice that the brown and red wires are connected, and they had that 190 ohms of measurable resistance. But look over here, the connection between the blue primary wire and the winding is broken. Now, after excavating fairly deeply into this output transformer, I believe I have found the other end of that broken wire. We'll have to see if this has continuity with the center tap, and if so, then I'm going to try to surgically reattach these two wires together and make the output transformer work once again, hopefully. Okay, now you're going to be able to see and hear the noise coming through the speaker. Watch the ohm meter. There's no doubt then it has continuity with the center tap. So that is the other end of the broken wire. Now, to get the microscopic wire to jumper between the two ends of that open winding, I'm going to tease some wire off of an old voice coil. And I'm hoping you can see the little solder joint right there at the end of the screwdriver. Okay, now using epoxy to stabilize everything, I brought that wire down here and wrapped it around the pigtail that goes to the first 6BQ5 plate. Then, to stabilize and protect this whole side of the winding, I coated it with the high temperature black silicone. Okay, now let's check for continuity across our primary winding of the output transformer. Here is the second tube's winding, 141.9 ohms. Here's the first tube's winding, the one that I repaired, 155.1 ohms. So it appears that the repair was indeed successful. Okay, let's turn this beast on and see what kind of voltage we get on our first 6BQ5 plate. We'll be monitoring it there. Turn it on, and here it comes. Peaks at around 308, and now it's going to drop down to operational levels, where it stabilizes at around, 293 or so. And just to make sure the amp's working, I'm going to touch the input blade, and you can tell this amp is working great. It has really good volume. Not sure about the tone yet, but it appears that the circuit is repaired. Hey Rusty, how are you doing? You ready to help? Ready to get to work? No? I think you're ready to hide behind the Jeep. Okay, I'll let you rest while I do everything myself, for a change. Well, that's about it for today's video, chronicling a very unusual problem in a guitar amp and an equally unusual solution. There are other causes for motorboating in an amplifier or radio circuit. It's almost always due to a charging and discharging of a capacitor within the circuit, and this was probably no exception. Although the initial cause of the problem was the lack of continuity within half of the primary winding of the output transformer, I believe the noise is actually caused by the charging and discharging of a filter capacitor within the circuit. Fortunately, once continuity was restored, the capacitor ceased to do that. I'll leave it up to electronics wizards way above my pay grade to figure out why. Meanwhile, we're glad that you joined us. We really appreciate the time that you spend watching our videos and commenting on them. And we hope that you stay tuned for future releases. Until then, it's over and out from Rusty and Uncle Doug. Rusty, are you ready to thrill your fans out there in YouTube land? We have a little chicken treat here for you. Are you going to sit? Good boy. Now speak. Don't stand up. Speak. Speak. Speak.